So we are now moving into the third phase of the software development life cycle. This is where we are actually going to begin programming the application itself. Now, again, a reminder of the SDLC cycle. What we are taking into this phase is going to be both the requirements document that was created in the first phase to help us understand the milestones that we need to reach, as well as all of the design documents, the flow charts, the wireframes that have been created so we understand how our application is going to work and what it is going to look like. Getting into the code generation phase, we're going to discuss some programming languages. Now, you do not need to have any programming language experience to understand this, although for those who are actually developing the applications, you will of course need that skill. Before we begin, though, I want to introduce you to 4 key elements of application design and development that I want you to understand. The first is a tool called a compiler. Now, what a compiler does is it will take the code that has been written by a developer and convert it into the machine code that computers understand so that it can run. We also have a tool called a debugger. Now, a debugger helps find any problems with your code that is preventing it from compiling or executing. If it sees any problems that are syntax related, a missing bracket, parentheses, calling a function that doesn't exist, these are the tools that will help you to find those problems and fix them. Also, there is something called a software development kit, an SDK. These are absolutely critical to the development of mobile applications because they provide you with a significant number of code libraries that help you to develop for different platforms. To explain very simply, there is a considerable amount of code that your application will need to execute on a platform. However, since that code is always going to be required, there's no reason for you to ever have to create it again and again or for others to create it on their own. These libraries are programmed, packaged, and put together into this SDK so that if you want to develop for, say, a certain version of Android, you don't need to recreate all of the necessary code to interact with the Java operating system. You have it right there in the Java library so that it can do it for you. All you have to do is load it into your environment. That environment, by the way, is something called an IDE, an Integrated Development Environment. This tool takes all of the tools that we have just mentioned and more and combines it into a single utility for developers to be able to create applications from that single source. Now, when it comes to programming languages and the code, in the field of computer science, there is so much to consider that we can divide it and cross it and cut it and sectionalize it in so many different ways. But for the purposes of this training, we have cut them down into 2 different categories of code. There is scripted code and compiled code. Scripted code, the important difference to understand, is that this code requires something called a runtime interpreter. This is a program that takes the code that a programmer has written and converts it as the program is running into the machine code that is needed to be understood. Compilers, on the other hand, will take that source code and put it into the machine language ahead of time. That's why we are referring to that set of code as compiled code. So let's dig a little bit deeper into these. And let's start with scripted code. And what we're primarily looking at here with scripted code is going to be HTML5 applications. Now, HTML5 applications exist as mobile websites, and when we are talking about this, we need to divide it down further into 2 different categories. There is a client-side scripted code and a server-side scripted code. The differences between these? Well, let's actually look at the different languages that are out there. If we look at some of the client-side scripting languages, the most common ones you are going to find are no different than you would find for non-mobile website development. HTML, CSS, and JavaScript. We'll get into those each a little bit more later. And on the server side, Usually you find a wide variety of languages, but for the sake of brevity, we are going to talk about simply server-side code is used to dynamically create web pages for people. And we are also going to talk about something called SQL, Structured Query Language, and why that is so important. In the discussion of scripted code, we're going to look at the client side first. Again, this is going to be the HTML, CSS, and JavaScript. Getting into the first one of these, HTML, Hypertext Markup Language. This is the backbone of the internet. When we are looking at a web page, we are looking at documents that are scripted in HTML. Think of this as the frame of a car. It is the skeleton of something that defines where things and how things will be structured. And you can see from this example there are some elements in there that are pointing out in the actual web page where those different HTML tags are affecting the presentation of those different elements. Moving into CSS, or cascading style sheets, this is a recent innovation, a few years old, that has allowed us to separate the presentation, how something looks of a web page, from the actual structure itself. So a very good example of this would be if you had a website and you had 500 HTML files on it that all said the website background color was going to be blue. And then one day you are instructed that the background color will now be green. Well, prior to CSS, you would need to go and modify every single one of those files. With the integration of CSS, however, we can actually define the background color for all 500 pages from a single document and a single line of code. You make one change in that line and the rest of the website is affected. Here's an example of it in action. We can see in the top left that's just the HTML, and without any kind of CSS definitions, we look below it and we can see what it would appear as on a browser. However, with the implementation of CSS definitions, as we see in the top right part of the screen, we apply those two together and the result in the lower right is going to be dramatically different from what we see in the lower left. And this does not modify the HTML at all. It's completely separated. This is one of the major benefits of CSS, is that separation allows you to affect things site-wide without actually making any changes to the HTML itself. So going back to the car analogy, if HTML is the frame of the car, think of CSS as the body, what it looks like. JavaScript. Continuing that car analogy, this is the engine, the drivetrain. It is what makes your car do something. JavaScript enables your website to interact with the user, to be dynamic, to respond to mouse over or click events. JavaScript is even so powerful, it can actually send requests to the server and get responses back without the user actually doing anything. If you've ever tried to sign up for an account with a website and you type in the username you want, and then it comes up and says, sorry, the username is already in use, that's powered through JavaScript. Now, JavaScript is a very powerful language. However, it's also very tedious, very meticulous to write. There's so much to it. So enter a JavaScript library called jQuery. Now, jQuery allows us to very, very simplify JavaScript. If you take a look, here is an example of something in JavaScript. It's going to change a color. And below it is an example of that exact same instruction, but through jQuery. You can see it's less code. And if that wasn't enough to convince you that jQuery makes things easier to program, let's have a look at this. Above is a JavaScript function that will fade an element out into complete transparency. The equivalent in jQuery is the single line of code that you see below it. Why is this important? Because client-side scripted code is transmitted from the server to the client device. If you can reduce the amount of data that you need to transmit to that device, then you actually keep more network availability open for more users. If it's very congested, it will be very slow, less code, less congestion, more users, faster experience. Let's talk about that server side now. Let's look at the server side code. And let's begin at looking with dynamic page creation. Here is an example of where what is called a query string provides a value to the server. We have the exact same web page with a bit of server-side code, that block of PHP that you see in there, where all it does is it takes the value provided from that query string, it inserts it into the web page itself, and then returns that page with that value in it to the user on the client side. So depending on the variable that we feed into the query string, we could get a different response. And here you will see the exact same code from the server side will give different results, both in how it looks and the code itself on the client side, with regard to whether or not we feed it the value Tarek or Aisha. We also have something called SQL, as I mentioned earlier, Structured Query Language. Now this is a language that is very powerful, and you must be very careful when you use it. And the reason for that is because this language has direct access to the data itself. Not only can it access it, it can actually modify the database structure. This is something we need to be very careful with because of something we call SQL injection. Here's a sample of such an attack. We see an SQL command to update the population table and set the name equal to a variable. What's the value of that variable? We're going to pull that from the query string, just as we saw from the dynamic page creation slide. Although, one small problem. Have a look at, in red, the value that I have given. That's not a name. In fact, that's something else entirely. But when we combine those two together, have a look at the resulting command. We don't have one command now, we actually have two. I have injected a stop command into my SQL feed, which tells the server, now you're done. But I have also injected other commands, which the server will then interpret as, and now process the rest of this. So if I say that my name, which is going to be put into the command, is drop table population, the result of that injection attack will be whatever update is called for by the original command, followed by a second command that I injected. Delete that table entirely. And now that data is gone. The only way you will be able to recover it is from any backups that you may have taken, that you hopefully have taken. Program your code according to this. Keep security in mind. One very easy way to prevent this, who has a semicolon in their name? Nobody. If you see a semicolon in the name variable that is returned to you, that's bad data, and it should be rejected. More on security practices later. Let's talk now about compiled code. This is the code that we are going to use for native applications. It's compiled, it's put into a program that is then uploaded into an app store, downloaded, and installed onto devices themselves. Now, compiled code takes more resources to create than scripted code, and that is because we actually need to take that code that we have written and put it through the compiling process, as opposed to just putting the code out there to be ready for runtime interpretation through scripted code. And we can break it down into two categories that we are going to discuss. There is unmanaged code, and there is managed code. The differences between these, we'll get to them right now. Unmanaged code. This is code that has direct access into the operating system and the resources that it provides. As you can see in this example, any applications can interact directly with the mobile operating system, which itself has direct control of the hardware. Some examples of programming languages that can do this are C++, which is used for BlackBerry applications, and Objective-C, which is used for iOS applications. So this code talks directly to the operating system, which can result in some potential problems if we have bad development practices. For example, let's suppose we have an application that someone opens and they then log in. So when they log in, they provide their username and their password. Well, we need to be able to store that information somewhere so that we can verify it. That information is stored in memory. Access to the memory is controlled by the operating system. That information comes from the application itself. However, the operating system never decides when memory is no longer needed. It waits for that instruction to come from the application that requested it. So, if we created an application that stored these variable values in memory, but then either the program crashes or we didn't program the application to clear and release that memory back to the operating system when it was done, after the application closes, those username and password values could still exist in the memory space of the device itself. All you need now is a piece of malicious code to come along, scrape the memory space of the device, and someone could find the credentials that were used. Now, it's worth noting that even though we mentioned Objective-C is one of these, this is not something that actually happens within an iOS environment. Apple has created their iOS environment to function along the lines of what we are going to discuss now, which is managed code. Managed code, much like what we saw before, actually has an additional layer between the applications and the operating system. This layer is often called the manager. And a Java, this would be the Java runtime environment. We have Java also as one of the managed languages that is used for Android applications. We also have C#, which is used for Windows Phone applications. Now, one of the nice things about the manager is that even if you have bad programming practices in the applications itself, that middleman, that layer, the manager, catches these things and fixes it for you. So let's go back to the earlier example we had. Let's have a look where, again, someone opens an application, they log in, they provide their information, and those values are stored in memory. And once again, let's suppose that the application crashes or the application exits and we never put the code in there to say, erase that memory and release it back to the operating system. Not a problem. The manager tracks what memory space is in use by any given application at any time. So when an application is no longer running, the manager detects this, identifies the memory space that was used by that application, and cleans it and releases it back to the operating system. So we have scripted and compiled languages and the two different segments within them. Now let's talk about combining these two together into our hybrid application. Simply put, native plus HTML5 equals a hybrid application. Now, with hybrid applications, every single language, every single benefit and risk that we just talked about is something that you are going to have to keep in mind. You are going to have to develop compiled code for the native part of the hybrid application, and you are going to have to build scripted code, both client-side and server-side, for the scripted side of the hybrid application. It's important to understand that this is a large burden on developers. They have so much to work with to collaborate and make sure that these two sides will match up together. It's possible, but it's another reason why we say a hybrid application is very intensive in development. So, developers, keep note. One of the things that managers are going to expect from you is your knowledge, your expertise, and your guidance on what application type should be used for a service that is going to be delivered. They are going to need your help with this. You do not want to produce an application that requires the use of a microphone but was designed to be an HTML5 application. That won't work. The only way you'll be able to access that hardware is through a native application or the native component of a hybrid application. So managers, be sure that your developers are involved in that first phase of the software development life cycle. Someone who can bring this very low-level technical knowledge to the table when it comes time to discuss how a service is going to be developed.